In this video, we're going to look at some examples of getting the integral of a product of an exponential function, a sine function, or alternatively the same method applies for an exponential function and a cosine function. The first example we look at here is the integral of exponential x times sine x dx. So we're going to do this using the rule of the integration by parts, which is the rule up here. So the first thing we need to do is identify u and dv in this equation. So if we come up to our rules here, go to rule number 1. If one of the factors is a log function, it must be taken as u. When neither of these functions are log functions, we move to the second one. If there is no log function but a power of x, this is taken as u. But once again, you can see that neither of these terms is x to the power of n. So we go to our third rule. If there is no log function or power of x, then exponential x is taken as u. So that tells us that we take u is equal to exponential x. That gives us dv is equal to sine of x dx. So then what we do is we get u and v. So to get u, we differentiate u over on this side. So the u dx is exponential x itself. That implies that du is exponential x dx. On this side, we integrate both sides. So the integral of dv. On this side, we have sine x dx. So this will give me v on the left hand side. And the integral of sine x is minus cosine x. Now what I should say is to do these is we have an iterative process here. So we will say that I is equal to the original function, the integral of exponential x times sine x times dx. You'll see now what's going to happen is we're going to go through this process twice, and we'll end up with this term here that we started with will appear again after we go through the process twice. So if we go and apply the integration rule once, u dv is equal to u. So u is exponential x times v. So v is minus cosine x times the integral of v, which is minus cosine x, times du, which is exponential x dx. So if we tidy it up, we can bring the minus sign to the first, to the start, and the cosine function to the start. So minus cosine x times exponential x, with brackets just to separate there, minus, and we have a minus times a minus, giving me a plus, times the integral of exponential x, I'll just swap these around, cosine x dx. So I just swap the exponential and the cosine around, and this is equation 1. So we have the integral exponential x sine x dx gives us the term minus cosine x times exponential x plus the integral of exponential x cosine x dx. So what we have to do is run through this process again, where we're going to apply the integration by parts rule, but this time we're dealing with exponential x times cosine x dx. So we decide what's going to be u, what's going to be v. Well, following our rule again. There's no log function, so we skip to the next rule. There's no x to the power of n, so we skip to the next rule. The next rule says if there's no log function or power of x, then the exponential x is taken as u. So as before, I come here and take this is equal to u. That means dv is equal to whatever remains there, which is cosine x dx. So on the left hand side, if I differentiate that, I get du dx is exponential x. That implies that du, which I need for the formula, is exponential x dx. On this side, I'm going to both sides, so the integral of dv is the integral of cosine x dx. That implies that v is equal to the sine of x. So, once again, it's a case of plugging these into the formula. U dv is equal to u. So u is exponential x again. V this time is sine x. And that's minus the integral of sine x times du. Du is exponential x dx. Now if I rewrite that here, that is equal to exponential x sine x minus the integral of exponential x sine x dx. If you notice, that is the term that we started with. We were looking for the integral of that. And I said before that we would substitute in, wherever you see that, substitute in I. Because you're looking for I. So I substitute in I to represent this integral. So this is my second equation. If I go back to the first equation, I basically have exponential x sine x, and going back to this first one, writing it out, dx is equal to minus exponential x cosine x. I'll write it this, so I'm going to swap these because they look a bit neater, plus, and then I'm going to open a bracket here, and I'm going to substitute in what we got here for exponential x cosine x dx. I'm going to substitute this in. So it's exponential x sine x minus I. But remember that I also can substitute in I here. So this gives me I is equal to minus x cosine x plus exponential x. I multiply this out, sine x minus I. So I have I on both sides, and I is what we're looking for. So then I can take this back to the other side. This implies that I plus I, so I can bring this to the other side, is equal to exponential x, and I can swap the order of this. This is positive, this one is negative, so I'll bring that one over to that side. And that implies that 2i is equal to exponential x. I can just factor that out. So it's sine x minus cosine x. And that means I, which is equal to the integral we're looking for, exponential x sine x dx, that's what we're looking for, is equal to exponential x over 2 multiplied by sine x minus cosine x, and I'll add in the constant integration at the end. So when you have a combination of exponential function of either sine or cos, you set the initial function equal to I. You run through the integration once to get this equation. You then take this here, integrate this again here, and you'll find that when you've gone through this process, you'll find that in here you'll find that you'll find the I term in here as well. So then, if I write it out, I substitute it in here. That's the integral of exponential x cosine x dx. If I put that in there and substitute it in, I'll get the I on this side, I on that side. I bring this one over, and then I brought all the i's to the left-hand side. And that's what you're looking for. Okay, so that's one of the easier ones. They get a bit more complicated when you start putting coefficients in. So we look at one of those examples now. So this example here is a bit more complicated than the last one because our exponential function is now exponential 2x. And the cosine function has a constant in front of the x, so it's cosine 4x. So the first thing we do when we see this integral is we come along and we said I is equal to this. So you'll see that that term repeats. We're going to integrate this twice. We're going to go through the rule of integration twice. So the first thing we need to do is identify u and dv. From those, we'll be able to work out v and du, which we need for the formula, for our formula. So what we then do is come through our rules. So we have the rules are here. The first rule says if there's a log function, that should be set to u where we know log function. So if that's not the case, if there's no log function but a power of x, that's taken as u, where we have no power of x. So we can skip to the third rule. If there's no log function or power of x, then x, the exponential term, is taken as u. So we say u is equal to exponential 2x. dv is everything else. So dv is the cosine of 4x dx. So we run through the process where I differentiate the left-hand side. So du dx, and by the chain rule, is equal to exponential 2x for the outer function. And the inner function, the derivative of 2x is 2, so I can put that in front. On this side, if I integrate both sides, cosine 4x dx. So the integral of dv gives me v. And the integral of cosine 4x is sine 4x divided by the coefficient of x, which is 4. So I have all the values I need to plug in. So I say u dv is equal to, the first one is u, which is exponential 2x, and we have v, which is sine 4x over 4, minus the integral of v, which is sine 4x over 4, times du, which is 2 times exponential 2x dx. I've got to bring up the du here, so we can say du is 2 times exponential 2x times dx by bringing my dx up. I can then just tidy this up, so that's exponential 2x times sine 4x over 4 minus the integral, and I have 2 here divided by 4, so that gives me a half. 2 divided by 4 gives me 1 over 2, which I can take outside. And that gives me exponential 2x, swapping the order of these around, times sine 4x dx. So of course what we have to do here is that's equation 1, is integrate, take this lot here and integrate this. So the second part of it is to integrate this. So with the integral of exponential 2x sine 4x dx. So once again, we set the u equal to the exponential term. dv is everything else. So it's sine 4x dx. Sine 4x here dx. And so on this side, what we do is differentiate the left-hand side. So it's exponential 2x. It's the outer function. And the inner function is derivative is 2. On this side, I differentiate both sides. So integral dv, integral of sine 4x dx. So that tells me v is equal to the integral of sine 4x is minus cosine 4x divided by the coefficient of x, which is the 4. So if I take those values and I plug them in, u dv is equal to u, which is exponential 2x, times b, which is minus cosine 4x over 4, minus the integral of minus cosine 4x over 4, and my du is 2 times exponential 2x dx, because once again I have to bring this up. So du is 2 times exponential 2x times dx. Bring dx up. So if I tidy this up, I have minus exponential 2x times cosine 4x over 4. I have a minus times a minus here to give me a plus. I have 2 divided by 4 to give me a half, which I take outside. And this gives me exponential 2x cosine 4x times dx. And of course we've seen that before, because that's what we start off with. So that tells us that we have minus exponential 2x cosine 4x over 4 plus a half times I, like so. So this is 2, and the next job is to substitute 2 into 1, where 2 is the integral of 2x times sine 4x dx. And that appears back up here in equation 1. So if I write out equation 1 again, if I write out equation 1 again, the integral of exponential 2x times cosine 4x dx, that happens to be equal to I, is equal to, and then we go back up to equation 1, it's exponential 2x times sine 4x over 4 minus a half times the integral of exponential 2x times sine 4x dx. So that I've written back out, basically I've written out equation 1 again. This is equation 1. So now what I'm going to do is substitute equation 2 into it. So this tells me that I'm not repeating that part, I just have the I here, is exponential 2x times sine 4x over 4 minus a half, and then I'm substituting this bit here in. So it's minus exponential 2x times cosine 4x over 4 plus, I'm sorry, it's this one I'm substituting in, plus I over 2. And then if I multiply this out, that implies that I is exponential 2x times sine 4x over 4. I have a minus times a minus here to give me a plus. That's exponential 2x cosine 4x, that's there. I have 2 times the 4 here to give me an 8. And here I have minus a half times I over 2, so that's minus I over 4. Multiplying the 2 by the 2, and it's minus, so it's minus I over 4. Then what I do is I bring the minus I over 4 to the other side. So that implies that I plus I over 4 is equal to exponential 2x, which is common to both of them. The 4 is common there, so that gives me sine 4x plus cosine 4x, in this case is divided by 2, plus my constant of integration. So I factored out a 4 from here and a 4 from there. And then that gives me, that implies that 5 over 4 times I is exponential 2x over 4 times the sine 4x plus cosine 4x over 2 plus the constant of integration. And then what I can do is just bring the 4/5 over. So if I bring it across, I'm dividing by that. If I divide by 5/4, it's the same as multiplying by 4/5. So I bring it across and multiply. If I multiply both sides by 4/5, basically the left-hand side will disappear. And then I have exponential 2x over 4 times sine 4x plus cosine 4x over 2 plus c. When I say it disappears, it's 4/5 multiplied by 5/4, so it just gets 1 basically. This tells me that I is the 4's cancel, so it's exponential 2x over 5 times sine 4x plus cosine 4x over 2 plus c. If I really want to get rid of that off the bottom, I can say it's exponential 2x over 5 times 2 times the sine of 4x plus the cosine of 4x over 2 plus c. And then I can take that outside. So it's exponential 2x. 2 times 5 is 10 times the 2 times sine 4x plus the cosine of 4x plus the constant of integration. So that gives you the final answer. And of course, I is the integral you started with, which is 2x times cosine 4x dx. And that is the answer that you're looking for. So it's quite complex, but it's typical of the exam question you get, so you need to practice. Okay, that's that section.